Let's now see why we need loops and iterations. When we create new process or new function, we want to operate over some data. While we are processing our new data, we will have many cases where pattern of our processing will be the same. In those cases, we won't write 100 times one specific implementation which will operate over many different structures or variables. Let's now see what is structure of our loops. First loop which we will create will be for loop. This loop has three different stages. In first group, we initialize our new variables. In second group, we are checking specific condition. And in third group, we are creating our post process. This form is our standard for loop. So now let's create a real example. To declare our new for loop, we will write reserved word for. After that, we will initialize our new variables, which we will use inside of our loop. We will create new variable s with value 1. Then we will write specific condition which we want to check on each iteration. In this example, our check will be that s must be less or equal than 10. Now we are creating our post process. This means that after each iteration and before we start next iteration, we will execute that process. So in this case, we want to increase our s variable by 1. After we define all three groups, we create new block. Inside of this block, we will write our code. So in this example, we want to print value s on each iteration. Let's go through each iteration. On first iteration, we will have s variable with value 1. Then we are checking if value of s variable is less or equal to 10. If our condition is correct, then we will execute code inside of our block. So in this case, we will print value of our s variable. After that, we are not starting next iteration. Instead of that, we will execute our post process, which means before next iteration, we will increase our value of s variable by 1. After we increase our value, then we will start next iteration. But now, in second iteration, our s variable will have value of 2. Then again, we are checking our condition, and now condition is different. We are checking if 2 is less or equal than 10. Because that condition is also true, we will execute code inside of our block. After that, again, we will increase value of our s variable by 1. Now you can see the point. We will go further like that until our condition in second group fail. So let's say we had 10 iterations. First 10 will be successful. When we start next iteration, we will get scenario like this. Now our value of s variable will be 11. When we are checking our condition will fail because 11 is not less or equal than 10. Because our condition has failed, we will break our for loop and we will go outside of our for loop. That means that we will continue to execute our code after this for loop. So in this case, we will continue to execute code from line 10. Our first for loop will have output like this. Let's now create another form of our for loop. Before that, we will initialize new variable f with value 0. In this form, we will also write reserved word for, In this form, we will have only condition which we want to check. In this example, we want to check if our f variable is smaller than 10. After that, we just open our new block. Inside of our block, we will specify specific code which we want to execute. So now, in this for loop, we didn't initialize new variable when we started our loop, and we don't have post process. This form of for loop is also known as while loop. Let's now create code inside of our block. In this case, we want, when we start each iteration, to increase value of a variable f by 1, and after that, we want to print that value. The real question is, what if we have some scenario in which we don't need to go to next iteration and we want to break our for loop? For that, we have another reserved word inside of our language. How we can execute that? We will check special condition for our for loop, and then if that condition is successful, we will use inside of that block reserved word break. In this case, if one of our iterations after execution inside of our block have value of f variable equal to 5, we will break our for loop, we will go outside of our for loop, and we will go to execute code after our loop. In this case, we will print only 5 values, and when we get to value 5, we will break our for loop. If we need case, when we need to execute all potential values of our specific variable, in that case, we won't write our break. So that example will look like this. Inside of first while loop, we had break. In our second while loop, we don't have break. We execute our code for all potential values for our f variable. So in our second while loop, output will start from number 6 and it will go until reach number 10. Because in that case, in our for loop, 10 is not anymore less than 10, and that condition will fail. This was the second form of our for loop. Let's now see how we can operate over third form of our for loop. We know how we can break on a specific place our for loop. What if we have scenario where in our for loop we have state which is not important to us, and we want to skip that iteration without execution of our code? For that, we have reserved word continue, so we can skip that specific iteration and go to next. In our second while loop, on a line 24, we have special condition inside of our block. When we increase our f value by 1, we are now checking if value of f variable is 8. In that case, we will continue to next iteration, which means that our code on line 27 won't be executed. When we add lines 24, 25, and 26, our output won't be the same, because now our output won't print value 8 inside of our block, and new update of our output will look like this. So now we learned how we can break our for loop on specific place, and also how we can skip specific iteration in case where that iteration is irrelevant for us. Let's now see third form of our for loop. As we can see, this form of for loop in declaration doesn't have any of these groups in previous examples. That's why this form is also known as infinity for loop. In this example, First, when we start infinity loop, we will increase value of our f variable. Then we want to check values in specific scenarios inside of our for loop, like this. Now we have new condition. In case where value of f variable is equal to 13 or 15 or 17, we want to continue to next cycle, which means we want to start next iteration. In that case, code after our condition, if condition is successful, won't be executed inside of our for infinity loop for that iteration. Let's now add some more code. If first condition fail on line 33, we will start to execute line 37, and then we will print value of our f variable. After our printing value of our f variable, we will have new condition. We want to check if value of f is greater or equal than 20. In case where this condition will be successful, we will break our for infinity loop. In case where this condition fail, we will just start new iteration inside of our for loop. So after our infinity loop finish execution, the output will look like this. In the output on line 43, we can see how our infinity loop printed our values. We have 11, 12, and then we don't have 13, because for that case, our first condition inside of our for loop is successful. Then we will go to next iteration. We have 14, and after that, we don't see 15, because also for value 15, our first condition is successful, and for that case, we won't print value of our f variable. The same pattern applies in case where value of our f variable is 17. That's why we don't see 17 inside of our output. Also, we noticed that we have numbers until 20, because for that specific value, our second condition will be successful. For value 20, our condition where f variable is greater or equal than 20, we will break our infinity for loop. For that case, we will go outside of our infinity for loop and we will execute line 42. Now we covered 3 forms of our for loop. In the next video, we will see a couple more examples for our for loop.